This is Algebra 2 Trig, Chapter 4, Section 5 on determinants. Talking about matrices. This is a new action called a determinant. Explaining what a determinant of a matrix is actually kind of not complicated, but involves something that we don't need to worry about right now. So before I explain what a determinant is, let's talk about how to find them. A determinant is a single number that we pull out of the matrix that kind of expresses its value. Sort of. It expresses what the matrix can do if you apply it to things. But the key to it is it's a single number, it's not a matrix. We show it with what looks like these absolute value bars. Now that does not mean absolute value of matrix A. I'm not doing the absolute value. When you see the absolute value bars, it means you're doing a determinant. Finding a determinant is actually quite simple, especially the small little matrix. I'll start with matrix A, B, C, and D. If I wanted to find the determinant of that matrix, I do A times D and B times C, and I subtract those from each other. AD minus BC. Whatever that number equals, that's the determinant. So here to find the determinant of A, I do 1 times 4, and I do that minus 3 times 2, or 2 times 3, really. That becomes 4 minus 6, which is negative 2. That's the determinant, negative 2. For B, I would do 15 minus 0. And if you want to pause and try C before I do, it's probably a good idea. I'm going to do it in one color at this point. 60 minus negative 6. 60 minus negative 6 is 66. Those are my 3 determinants of matrix A, B, and C. You can only find determinants of square matrices. We can't do it for non-square matrices. They have to be square. If they're not square, it can't be done. Here is a square, Here's a square 3 by 3 matrix. 3 rows, 3 columns. The process here is a little bit more involved, but it's really not anything awful. First, I'm going to take these 2 rows and copy them down again. 2, 5, 0, 1, 1, 1. And now I'm going to have strings of numbers that I'm going to multiply and add. And I'll show those with a highlighter. I'm going to multiply and add this string, multiply those, multiply those, multiply those, and add all those up. So that'll give me, right here, 2 times 1 times negative 2 is negative 4. 1 times 4 times 0 is 0. Negative 3 times 5 times 1 is negative 15. And that is one of my collections of strings. Then I'm going to do my other collection of strings. I guess I can't erase that too well. Forget that. Let's go the other direction. Zero times 1 times negative 3. 1 times 4 times 2. Negative 2 times 5 times 1. Zero times 1 times negative 3 is 0. So this string right here gives me 0. 1 times 4 times 2 is 8. Negative 2 times 5 times 1 is negative 10. I add all those up, and I'm going to subtract the difference between those 2 strings. Excuse me, somebody's calling me. Okay, I'm back. Mr. Reagan was being very rude when he called me. I mean, him calling me was rude, that's what I'm saying. We're good. I'm going to keep going. Negative 4 and negative 15 is negative 19. 8 and negative 10 is negative 2. I subtract these numbers. I get negative 19 minus negative 2, which is negative 17. So I know that this looks like a big mess right here. It looks like it's just a big scribble of things. But if you do it with colors and highlighters, you'll probably find it easier. Let me kind of show, that was negative 17 that we just found, another determinant. Let me kind of show the system for how this looks. If I have matrix A, B, C, D, E, F, G, H, I. That's the matrix I'm working with. To find its determinant, I would first go A, D, G over here, B, E, H, C, F, I. Oh, I don't need that third column, excuse me. Just those two. And I do A, E, I, B, F, G, C, D, H. I add all those up in one string. And then I'm going to have another string, and I subtract those two from each other. My other string goes GEC, HFA, IDV. And whatever that comes out to as a single number is my determinant. Thank you.